Now we'll see a little more on this series combination. That means we'll learn now that how this all resistance will act or work together in the case of a series combination. And drawing this out this side. So in series combination, these were our resistance. R1, R2, R3. These are the three resistors which are in series one after another. And then this whole resistance, this set of resistance are connected to a power source, to a battery. These all are connected to a battery which will give certain amount of voltage. And since the battery will provide the current or what there will be I, means current flowing through the circuit. To measure the current through the circuit, we need to connect one ammeter in the circuit which we will connect on this side. This is how the current flows, positive, negative. So here will be our positive, here will be our negative. Okay. This is how the current flows. Means current comes to the battery and goes to the resistance, all the three resistance, and then it completes the whole cycle. Now, the one important thing to notice or to remember is that whenever any amount of voltage flows through a resistance, there is a little amount of voltage drop. That means the resistance uses up some amount of voltage through any voltage from any current or from any power source when it flows through the resistance. So what will happen in this point, each resistance will have a separate voltage drop. That means this voltage coming through the battery will divide among these three resistors in series. Remember, in series combination, voltage divides across the resistance. So here, to check the voltage across each resistance, we will have to connect one voltmeter to each side. Voltmeter 1 to check the resistance of R1, means to check voltage across R1. Voltmeter number 2 to check voltage across resistance number 2, then voltmeter number 3 to check resistance across resistance 3 or R3. So as I told, across each resistance the voltage will divide. So V1 plus V2 plus V3 should be equal to the total voltage. The total voltage will divide across 1, 2 and 3 number resistance, and so the total voltage can be written as V1 plus V2 plus V3 for a series combination. So let us see here. So we know from Ohm's law V equal to I R. We know V equal to I R, which we learned in the Ohm's law. So voltage in 1 means voltage number 1 will be equal to current and the resistance of 1. V2 will be current and resistance of number 2. And V3, voltage number 3 will be equal to current and resistance to 3. Now see here one thing. In a series combination, voltage divides across each resistance, but the current remains same. means whatever current is flowing through the circuit will be same for resistance 1, resistance 2 and resistance number 3, and the same current will flow back into the flow throughout the circuit. So here current will not change, only the voltage changes. So using that formula, V equal to V1 plus V2 plus V3, we can substitute these values for the respective voltages. For V equal to, and writing IR, we substituted from here V1 I R1, V2 I R2 and V3 will be I R3. I R equal to, from these three we can take a common, which is I R1 plus R2 plus R3. So here I and here I will get cancelled because same quantities. So finally we get the total resistance to be R1 plus R2 plus R3. This is the formula for total resistance in series. This is R equivalent or REQ, which is, I'm writing here, total resistance in series. So this formula you have to remember, which is the total resistance in series combination. You can write it down, pause the video and you can write it down.